Hello, what's up? So we're in part 8 of this series. I'll just make sure my connection is going. How's everybody doing out there? Been a while since I've done one of these. All right, so we're doing hardest math problems for grade 8. Hopefully everybody's enjoying this. I got a few good comments from you guys about it, so thumbs up it. Takes a lot of effort and time for me to do this. And if you guys are enjoying it, just let's get something good going here. All right, so I'm going to pretty much jump straight into this because we're in a later part of this. So these are sourced from the New York State test, although these are problems that most kids got wrong. And we're talking about hundreds of thousands of kids then over a period of 10 years and so on. So these are the ones I think gotcha. They're not always just from straight up math errors. They could be attention to detail problems. They could be reading problems. They could be a whole multitude of stuff. They could be the category of silly errors, which also is about your math proficiency though. Greetings everybody. I see a few people in the lobby. If you guys want to try to do the answers yourself, definitely shout them out. If you have a question about something I'm not talking about as I'm doing it, I'll get to it eventually. Just have patience. All right. All right, so let me jump into this. Let me say again, I'm Greg from GregsTutoringNYC. You can email me at GregsTutoringNYC@gmail.com. I tutor for a lot of exams and also homework help and other things like that, and math, ELA, other subjects as well, science, social studies, depending on what's going on with you guys. But my specialty is standardized tests. So when we come to a problem, as you guys may know, whoops, let me get my, okay, that's going. I like to look at the illustration first. So we have an x-axis and a y-axis. Okay, well, according to geometry, it's radar, device, antenna. And we have units at the bottom going by ones. We have units on the left going by tens. So that's always important to notice when your scale or whatever, there's no legend to this. Anyway, the bottom's time, and the left-hand side is the number of revolutions of something. I don't know what. Okay. What I like to do is just look at it and see if I can find points like right there where two of the things meet when there's a line here. So we're lucky this line comes out of the origin. So if you know the equation of a line, it's y equals mx plus b. Okay, and this is all you should be doing without even looking at the words. These are just 2-second things you're going to be doing in your head to just get a bearing on what the question is even going to might eventually ask you. So there's no b here because it's 0. So we're looking at something that's y equals mx. Okay, so if we look at 2 and we come up across here, we get 30, right? So the m is the slope, which is your rise over your run. So we have 30 divided by 2 is what we end up having, because we have 30 minus 0 and 2 minus 0. So our slope is 15, right? And we know it's not negative because it's going the way it's drawn here. If it went the other way, by the way, a way to remember that is that if we do an uppercase N, this line in here actually has a negative slope. So whatever that direction is, that's our confirmation. So our slope here is 15. And if we go to 1, if we go up from 1 and then go across here, we can see it's between 10 and 20. So that's our slope. So there's really nothing else going on in this problem. We don't even know if we needed to compute the slope, but we're just trying to get our bearings. And these are instantaneous things. You just look at it. Oh, this is a coordinate grid. Oh, there's a line. Oh, it's starting from the origin. What's it about? It's about something about an antenna revolving somehow. I don't know. And I just try to look at some of the points. And since it's there, that's our constant of proportionality, right? Constant of proportionality. That word comes up in some tests, so that's a terminology question. So if we would go to 6, or what's a good, yeah, 6. If we went up from 6, 6 times 15 would give us the 90, right? So we're proving that's the case. And again, you're doing this in seconds, you're not, right? Not a big deal. So now we can go look at the words. A radar device has an antenna that revolves at a constant rate. Well, we just We knew that. And even if you didn't actually solve for the 15 here, now is the point where you would go down and look at it and actually get that number. The graph shows the number of revolutions the device will make over time. So again, we proved every minute it goes 15 revolutions. Okay, we don't care what the antenna looks like. We don't know where it's installed, how it's working. They're just telling us something and we go with it. Okay, so what I'm going to do is I'm going to scroll those top words off and even some of the top of this here to start getting in some of the answer choices. So we have 4 tables which should be equal to what that graph is. Okay, which table shows the data for an antenna? Which data are they talking about? They're talking about the data that's graphed here. The 1 and the 15, the 2 and the 30, the 6 and the 90. Whatever you see on that line, that's the data. Okay, the line is the data. So which table shows the data for an antenna that revolves around at exactly twice the rate of the antenna that was described in the graph? So the first question we have to answer is, what's the rate? The rate was the 15. It's 15 revolutions per minute, right? So what we need to find is which one of these matches that. So it's got to be 15 times more. So 15 times 15 is not 315. 30 times 15 is not that. Okay. Okay, 20 times here doesn't give us 2 either. So it's not A or C. And we look at B and D now and see if we can get that 15 out of it. This kind of gets hard because you have to figure out 18 times 15 and 36 times 15. But you should start seeing that it doesn't make sense that 18, it would start needing to be around 30 or 20 something in the high 20s, even for this one, right? So that doesn't seem to work, although we didn't rule it out. And if we look at this, we can get that straight up, that would be the answer. We could also spend the time to do the divisions and so on these as well, and or the multiplications to actually see if that number actually goes in properly, all right? So that would be our choice for that. Okay, this one. I might do a stream with this question alone by itself, so I'm actually going to skip it right now. All right, let me try to go to the beginning of this then. I'm going to skip this question. I might do a stream just, there's a lot of ways to solve that question. Actually, let me do this. Let me leave it up for 2 seconds. And anybody who wants to solve it can post it in the comments below or email me. Whoops. So that's the question. That's the choices. You can snapshot that or do it on the replay. All right, let me try it. That was question number 1. Okay, so again, we're going to look at the illustration. We have an X and a Y. They're going by ones. You should just know looking at this is scatter plot. It doesn't need to tell you that. And you should almost mock up a kind of line of best fit, if you will. So we know the line's going to go something like this. If we would try to draw it equally through all these, that's probably the line of best fit, somewhere along like that. We don't know where it's going to go. This dot's all over the place. You could argue that might be an outlier. Okay, maybe even that. Otherwise, everything else kind of seems to be in place. There's really nothing going on. There's no title. We don't know what the data represents, and so on. All right. So let's go back to the words. A set of data is represented on the scatter plot below. Okay, so that's pretty clear. There's nothing deep there. which equation best models the set of data. Okay, so there's a couple ways to approach this. Let me try to get those all on the screen at once. Okay, so we have, similar to before, we have y equals mx plus b. That's our equation of a line. And I did this maybe 2 sessions ago. But we can also write this as b plus mx. And furthermore, the fact that it's plus b and plus mx doesn't mean that they're positive values. So technically, we can also have a negative version where there's minus mx minus b or minus b minus mx, right? Those are all choices and all the permutations through there. So we could have minus mx plus b, minus mx minus b, and the flip form as well. So I'm mentioning all this because some of these are not always written in that form. So these are. So since, like I just said with the case with the n, okay, this is a negative slope. So therefore, the answer can't be b because 3/4 is positive, and the answer can't be y because 6 is positive. So we're left with a and c, with both have negative slopes. So it has to be one or the other of those. Okay. The second thing we can do is that it gives us the b. Okay, that's 6 is the b, and this 3/4 is the b. So that's the y-intercept. When x is 0, that's where it's going to be. So this line actually came to here, so perhaps a better way to have drawn it was probably that. Okay, so since it seems likely that the green line can work with A and not with C, if it was C, it would be all the way down here at 3/4. So somehow it would still be negative, but it would go across like that or something. So for that reason, the answer would be A. But let's just double check that the rise over the run is actually 3/4, right? So if we actually went down from the 6/4, 1, 2, 3, 4, right? Oh, wait, sorry, it'd be 3. 1, 2, 3, and over 4. 1, 2, 3, 4. Yep, that brings us about to there. So that confirms that would indeed be the line of best fit. Okay, so that's really what they're looking for. The question never asked for the line of best fit, but that's what it's asking you to model. So that's kind of what where you need to be on it, right? Let me just make sure we're still live. So that's kind of what. Yes, we are. Let's see here. Okay, let's go on to the next one. So a lot of these, since this is grade 8, a lot of them are going to be about lines, exponents, things like that. And again, for you guys taking the SHSAT or other exams like the Academy test, the ISEE, the SSAT, even the PSAT and the SAT, the Bergen County Academy test, the TACHS, all these are concepts that you're needing to be doing and figuring out for that. So number 14 is kind of a pseudo question involving terminology, but not quite. It deals with your understanding of what a function is or isn't. This almost always comes up on a lot of these exams, which deals with, again, knowing the limits of the definition of what a function is. Okay. Okay, so which set of ordered pairs xy, right? This is a pair, we should know that they go together, could represent a linear function of x. Okay, so this again is the y equals mx plus b. Okay, there's other forms of a line, but this is the one that is kind of making sense to be at this level? So which of these, if we were to plug it in, so to speak, would work? So what we could do is start figuring out slopes and y-intercepts and plugging in the actual x's and y's. Okay, so this in a way could be a busy question. First of all, this is a set, so that's a curly brace. If you look on your keyboard next to the P, there's two keys, a right and a left bracket. There's also a right and left curly brace or squiggly brace or whatever you want to call it. So when you see this and the closing one is over here, that means that's a set. So this is an unnamed set containing 4 elements: minus 2, 8, 0, 4, 2, 3, and 4, 2. There's 4 pairs within each answer choice here. Okay? So there's certain things about a line that have to be true. And we talked about this and other things. A function cannot have 2 outputs for the same input. So B has that problem. For the same input x, which is 1, it has 2, 3, 4, and 5. That's not how a line works either. So for that reason, B would be no good. Okay? So does any other one have that? We have that for D as well. We have 3 producing 5 and 9. So what we're trying to do is circumvent having to force fit that y equals mx plus b by using our general knowledge about functions as well. So we can rule that out. Okay? Let's see, can we rule out C with anything that leaps out straight to us? Or A for that matter? No. So what we're probably going to have to do is figure out if some of the points lie on that by just doing our normal figuring out the slope. We can figure out M and then going to backtrack through that to see if it works. So this is a pretty annoying question. All right. Well, you could also plot it out if you have a piece of graph paper. And sometimes that's actually the fastest way to do it and to find out if maybe a dot is in the wrong place. So let's see. A goes from 8. It goes to 8 is the most, and D goes to up to 11. So let's try to do something like that where we can get 11 points on it. So if this is 10, then that's 5. This is 5, and that's 10. This is probably 5, and that's 10. This is about 5, and that's about 10. And let's just plot the points out. So we have minus 2. It's going to be about there. And minus an 8. So minus 2, 8 is going to be about right there. 0, 4 is going to be about right there. 2, 3 is going to be about right there. And 4, 2 is going to be about right there. All right, so that kind of seems to work. Let's change the color of a pen and check out another. We have 3, 5, which is about right there. We have 4, 7. That's about right there. We have, where are we? Oh wait, sorry, I'm using the wrong choice. Let me erase those. I'm doing D when I'm supposed to be looking at C. Not erasing it. All right, let me change the color of the pen to red maybe. So we have minus 2, 7. which might be about there. 0, 12. That's going to be about way up there. 2, 17. So that's going to be all the way up there. And then 4, 22 is going to be also all the way up there. By the way, we can almost see here on C that for every 2 here, this went up 5. So between -2 and 0 is 2. So what happens is they both look like a line. So now we have to actually go back and start working with the equation itself. Okay. So what I'm going to see is that there's a constant of proportionality here, which is that I noticed between here and here that a movement of 1 in the x makes it go, a movement of 2 in the x makes it go 5. So if I go 2 here, do I get 5 there? Yes. If I go back here, I'm going 4, right? I mean, sorry, I'm going 2 as well. So C seems to be the answer. Okay, and let's just see that that's the case here. This went by 2 to 4. So for this to be the same, this goes 1, 1. So those points are good. The question is, if I come back to here, does that work? 2, 3, 4. It should be 1, 5. I mean, sorry, -1, 5, -2, 6. Okay, so for that reason, A doesn't work. So the answer would be here. Okay. Which set of angle measures could be the interior angles of a triangle? Well, you should all know that the sum of the angles of a triangle is 180. So which of these choices adds up to 180? That's 270, no good. This is 360, no good. This is 150, no good. This is 165, 70. Yep, it's D then. Right? Simple that. Sum of the measurement of the interior angles of a triangle is 180. Let me make sure this is fitting on the screen properly. Yeah, it's good. Yeah. Okay, so there's a lot of words going on here, and I'm seeing things about triangles. So triangle BCD is rotated 180 degrees clockwise, and then dilated by a factor of 4. That means it's going to get larger. Centered at the origin. The resulting image is triangle B prime, C prime, D prime. So this apostrophe thingy is what happens when you move a certain point, a certain thing to somewhere else, and you kind of want to keep track of where it ended up. So we have a triangle that's basically expanded. That was originally at the origin. Which statement about the two triangles is true? So the area of BCD is 4 times the area of B prime, C prime, D prime. Well, if we have a triangle, even without rotating it, we have a triangle, and we make it 4 times as big. Do we end up with something like that? Right? Is that what it's trying to say? Okay, no, because if this length was 1, then we get 2 as the length. Okay. So that doesn't really work out when you actually do the equation and also try to fit it out. Since it's dilated by a factor of 4, it turns out we're going to get a triangle even twice that. We're going to be getting a super triangle like that. with the, whoops, I draw that sloppy, but it's, if it was originally 1, the length is now going to be 4 because it was dilated to that extent. So we're getting something probably was 16 times the area. Okay. The perimeter of, and by the way, this also has the issue that this is backwards. BCD was the original triangle. So if it got dilated, then the new triangle should be larger than the other one. Okay. This B has the same problem. The perimeter of the original triangle is larger than the perimeter. No, it was dilated. It was made by a factor of 4. This is not a fraction. It's not a decimal. It was expanded. It was made larger. So it's not A or B for the same reasons. And then if we look at that notion that the length of the side is 4 times bigger, right? So in that case, it would be 4 times the perimeter, but of the other triangle in reverse, okay? The corresponding sides are congruent. No, the length of the sides would be different. Congruent means the same size and the same shape, so it's not that. And the corresponding angles are congruent. So if I take a triangle and create a similar triangle to it, so in other words, if I have this, right, and then make it 4 times as large, if you will, if this right here, that dot angle and this dot angle, they're going to be the same respective angles. So will this one and this one. And so will that one and that one. So by dilating the triangle, you've created similar triangles. And similar triangles have congruent angles. So in that case, the answer would be D. Right? So some of these are about knowing your facts about shapes and so on. And others are dealing with lines and knowing formulas and things like that. What did I just do? I lost the page. Okay, so we have a lot of space being wasted on this page. Let me make sure that illustration is all there. Let me just make sure there's nothing underneath it, except for the question. Yeah, so they went. Can we get that with the question? Let's see here. By the way, this is an exam that allows calculators in certain parts. So some of you are doing exams that don't allow that. Whoops, that's not fitting on the screen. Let me just bring that down a smidgen. All right, I think that kind of fits. All right, so we have what looks like a cylinder with a kind of an inverted top, and that dotted line seems to be implying that there's a cone there. Okay, the object, and there's nothing really going on here. We have the bottom, the base of the cylinder is 4 inches, and the height is 8 inches, right? And then it seems that the thing for the cone right here, this height here from here to here, that's the 0.7 inches, all right? So that's what it seems to be implying there, right? There's nothing else going on there. So the object below is made of solid plastic. Okay, it is a cylinder with an indentation at the top and the shape of a cone. There we go. Okay, so let me try to scroll this slightly so we can bring that off the screen. What is the volume to the nearest tenth of a cubic inch of the plastic object? As always with geometry problems, there's a few ways to do them. So here they're looking for an exact number. This involves pi, so this starts to get annoying. In this case, you need to either do multi-digit multiplication or, like I said earlier, use your calculator. Let me just make sure. I'm going to keep moving this till it's still on the screen. All right, so what we need to do is use our formulas. So let me see how I can do this so I can keep this on the same. So the volume of a cylinder is equal to the area of the circle at the bottom, so that's pi r squared, times, that gives us 2 dimensions, times the height. So that's our 3 dimensions. Okay. What we want to subtract off of that is the volume of the cone. So the volume of cone, I'm going to just say co, is 1/3 pi r squared times its height. So what we need to do is take these 2 things and subtract them. Oh, you know what? Give me 1 second. I think that's falling off the side of the screen. No, it's the last thing there. Okay, so we're good. What we need to do is subtract 2 of them. We get the whole cylinder, we pull out the indentation part, and we should have what we have. So let's come back here at pi. Okay, since the diameter was 4, the radius is 2. So we're going to get 2 squared. That's a bad 2. Times 8. Here, let me redo that. I don't know what it's doing. It's not drawing it for me. Well, 2 squared is 4, so let me just do that. Times 8. So this will be 32 pi. Okay, we're going to have a similar thing here. We're going to get 1/3. Let me move it over here, actually. 1/3 pi. So we're going to have the same 4, because the diameter of the top of the cylinder is the same as the diameter of the bottom. Therefore, the radius is the same, so it's going to be 2 squared. We're going to get 4. And then we have 0.7. So that's where things get sloppy. So we don't know whether to write a 7/10 or 0.7. So let's just stick with 0.7 for now. And that's what we end up needing to do. So I'm gonna scroll this a little bit because we don't need any other information at this point. So we can kind of start getting the answer showing. So we can start getting a context. Especially as these end up being ugly numbers with ugly computations. So you might argue these are all large numbers so far. Yes, but remember on the left side we have 32 pi. So we're going to use like 3.1415. And again, if many of your calculators have a pi button, so you would just click 32 multiplied by the pi button in that case. And by the way, if you do this by hand, you may not get the exact same answer as these choices. Because if you use 3.14, let's say the answer was A, you might get 103.49 or something like that. So we have to use that to kind of make sense for some of this. Anyway, let's try to make more sense of the left-hand side. So we have 1/3 pi times 4 times 0.7. It's 4 times 7, right, is 2.8. Okay. And then we have to divide by 3. And then it would be pi. So it's a pretty weird number, but we can see this is about 0.9 pi, right? 9 times 3 is 27. So this is about 0.9 pi. So what I'm trying to do is avoid the actual multiplication, although you should actually do the multiplication as well. I'm just trying to show you an additional strategy. Now that we have the two numbers, you just need to put in your calculator 32 pi and then 2.8 divided by 3 times pi, and then subtract the two of them. These are normal calculator things. I'm just trying to show a way to do it without necessarily having to do that, right? So what we have is we can see that some of the answers don't come into play, like A and B are too high. Okay. If it's 31 times 3, we already have 93. So therefore D is out as well. So that only leaves C. Okay. So I'm just trying to show you guys a way. What that looks like the answer is C here. Okay, I'm showing you guys a way to double check it because I'm not going to spend time actually doing the calculation. If you do the calculation, you should get 97.61 or something, or 97.5999 or something like that. What they're asking you to the nearest tenth of a cubic inch. So if you happen to get like 97.5 something or whatever, it's probably because you didn't use enough digits on your pi. That's what makes this annoying. So if you use 3.14, you probably will not get 97.6. But if you use something like 3.11141596 or whatever, you probably will. But who wants to sit during a standardized test and actually multiply 31 times 3.14 or 15926 or whatever? So that's the trade-off there. So you should use both ways. You should try to solve it with the multi-digit multiplication, at least using 3.14, and you'll get very close. And then use the estimation way I just did here, which is that we know this over here is going to be about 9. Therefore, we know 32 minus about 9 is about 31. And then we're going to do estimation of 31 times 3.14. And we only end up getting C. There's not really an alternative here for that. All right. Okay, we're back to scatter plots again. So again, we're going to look at the illustration first. So it's players scored by basketball players. Sorry, points scored by basketball players. Okay. The bottom is in ones, but if you notice the strange notation where they kind of did a lightning bolt, if you notice this goes from 0 to 18 and then by ones. So what there is this more to this graph is what they're telling you. And it was basically white space. There was no points there. So they made the graph more compacted. Okay. Same for and that reflected the age of the players apparently. And the left-hand side is the average points scored per game of somebody of the age at the bottom. And if you notice, it jumps to 20, and now it goes by 2s, not by 1s. All right, so we always want to look at our X and Y that way and try to figure out what's going on. Now, that said, there does seem to be a line of best fit. Again, if we just basically mock it up here, somewhere along that line, so it's a positive slope. This looks like it's going to 0. But remember this lightning bolt thingies here. So there probably is a b. The b is not 0 with y equals mx plus b. There probably is a b. Okay? So not sure what else is going on with this graph, but it's points scored by basketball players of a certain age. Okay? So let's look at the words. The scatter plot below shows the average points scored per game by players of different ages in an adult basketball league. I ran out of stuff to draw. All right, let me try to scroll this away because we don't need that anymore. So there's this notion of association. So, and by the way, there was one more comment to make about the graph. This is definitely an outlier point. This 23, 20 is absolutely an outlier point. Okay. So the question is, which statement best describes the association between a player's age and the average points scored per game? So there was no association? Yeah, this seems to be an association that's positive because the older the person gets, the more points it seems they're scoring. All right. So B says there is a nonlinear association, except for point 23, 20. It surely looks like we can model a linear equation there if we amortize the points. So we can definitely get a linear equation out of there. So B is not right. There is a positive linear association and one outlier. Bingo. That's it. So let's just make sure that we didn't make some goof up and that D might be the answer. But so far, C is definitely the answer. There is a negative. No, it's not negative. And there's one outlier. So again, because there's a positive slope, that's part of what they're talking about here. So that's it. The answer C, as simple as that. This is pretty much a 15-second question. All right. By the way, I normally pick these off in about hour size things. So we're going 45 minutes. So let's see how long this question takes. Actually, I'm not sure what's going on here because all of a sudden my house is freezing. I think the heat cut off. Yeah, it definitely did. Let's see what's going on with that. All right, so this one has no illustration. So let's see where we're going with this. Let me make sure we're on the screen. Yes, we're on the screen. In City W, the average cost of a gym membership is given by the equation y equals 34.99x plus 49. So we notice that's a linear equation. The slope is 34.99. The y-intercept is 49. Okay, so in any event, what does it mean? What does those symbols mean symbolically? Okay, it says y is the total cost in dollars per month and X for X months of membership. So if you went for 1 month, you will be paying $34.99 plus 49. If you went for 2 months, you'll be paying 2 times $34.99 plus 49, and so on. So I like to use, this is similar to my cell phone plan that I have a running theme through a lot of these different things here. So what is the meaning when y, for y when x equals 1? Okay, if x is 1 here in this equation, it means you went for 1 month. That's it. That's what it's talking about. Okay? The $49 is your base fee that you're paying every month. Right? Because if you went 2, as I just gave the example, you would be paying $34.99 times 2 plus 49. So when x is 1, since x represents the month of membership, y must represent, when it's 1 month of membership, your total cost for 1 month of membership. And the only one that's that is C. So again, this is really basically another 15 or 20-second problem. Okay? It's just that easy. Just remember that when you see this, this is your base thing. Okay? You pay $49 just for having the account. And then on top of that, you pay per month. Okay? It's the same as your cell phone plan. You might pay $50 a month for a base services. And if you go over the services, normally it's gigabytes, right? If you go over the number of gigabytes, you start paying per gig or something like that, or per 10 gig. So that's the same idea. In that case, your cost might be in the cell phone plan. Let's say it was $10 a gigabyte. So you might have 10 times G plus, let's say your base fee was $25 a month. Okay. So if you don't go over, let's say 1 gigabyte, you're paying $25. If you do go over it, then if you use 2 gigabytes, you're paying $35. and so on. And different plans in different ways. There could be other features in here, because it might be another formula based on whether you have two phones or something, or whatever. But this is your general status quo kind of situation. That when you see that, automatically think that. And on the flip side, when there's a word problem, talking about something that has a base fee with something that's constant, right? Again, this 10 and this 34.99 is our constant of proportionality. That's what makes this linear. That's what makes it work. And you could say, how could it be linear if it depends on what the base fee is? That's the y-intercept, right? Because if we draw that, it means just to have a plan, which means you use no gigs, you're up here already. It means you already owe $25. Just the fact that you have an account. So in that case, your line would end up going like that, and it would go through this 0, comma 25, right? And then if you happen to use the 1 gigabyte, then it would add 10. If you use 2, it would add 20, because it's 10 plus 2, 10 times 2, or 10 plus 10. And if you use 3, you would end up 10 times 3 or 30, right? So, but your base thing will still be 25. It does not have to start from 0. It doesn't have to go through the origin, right? And it can still be a line. And these two are parallel lines. And the way to do that is the B changes. The B is different. That's how lines can be parallel. Ta-da! Okay? Because there's another equation, the green line, would be C equals 10G. That's it. There's no base fee. Let's say I charge you only for gigabytes. All right? So that's what's going on here with this kind of question. So be careful when you come into scenarios like that. All right, let me just make sure that we're live. Yes, we do. All right, let's see. Maybe I'll do one more. My head is actually killing me. Okay, that's showing good. Okay, what is the volume in terms of pi for a cylindrical container with a radius of 3.25 in height? So this is actually simple to the example I just did a minute ago, where we had to do the subtraction. Plus, not only do we not have to do the subtraction in this example, but they're letting us leave the answer in pi. Okay, so they're telling us this is a cylinder. The radius, which is half the diameter, right? Diameter is double radius. Diameter is 2r. Okay, this question doesn't ask about the diameter, but I'm just emphasizing d double, right? So that's one way to remember it, because this deals with your formulas too as well. And a height of 10. So anyway, this is 3.25. And the height here is 10. Okay, both are centimeters, so there's no unit conversion. Just like checking your X and Y graph and your legends and all this stuff, always check to see whether you have to do a conversion or not. Okay. Wait 1 second. The software's syncing. This is a good time to mention that if you're enjoying these sessions, please like and subscribe and give me some incentive. Yeah. Okay. So we did the volume before was pi r squared. Times h. And quote, all we have to do is plug them in. So we're going to have pi is still pi, okay, times 3.25 squared times 10. And that is what our thing is. Now, we can leave the answer in terms of pi. If you notice this pi there, there's pi there, there's pi there, there's pi there. So all we have to solve is 3.25 times 10. All right? So 3 times 3 is 9. And this is 0.25, so it's a little higher than that, right? Times 10 is 90. So our answer is a little higher than 90, which would be B. So if you actually sweat out and did the 3.25 squared on your calculator and multiplied it by 10, you would get B. Okay, you can also do 3.25 times 3.25 if you're on an exam without, that does not allow you to use calculators. You would just do 3-digit, multi-digit multiplication. Just remember, when you're done, since there's 2 decimal places and you see these numbers here, well, that's hard 2s and 3s. You would move it over 4 when you're finally done with your answer. Okay? So you would actually multiply those out, and you would end up at some point getting the 105, 625, 0, and then move it over 4 to get the 105, that's 625 out of it. Okay? All right? I'm not going to, my machine is slow here, and if I actually tried to do this multi-digit multiplication, it would take forever. Let me see how we're doing with time. We're 55 minutes. Let me look at the next question and decide whether to do one more or not. Because I have that number 7 from another one. I want to do that one by itself. And I don't know, there's about 10 more questions left, it seems. And I don't really want to do 2 more sessions for that because we're already doing this in 8 parts. All right, let me make sure this is showing on the screen. Yeah, it is. All right, so we have an illustration. It seems to be labeling these angles of this triangle as 2, 3, 4. 2 is the inner one and 1 is the outer one. I don't know where they're going here. They're obviously going to refer to it. So it says somebody claims that 3 plus 4, these two, is equal to the outside angle here. So does that make sense? This is actually a rule that you guys should know. And it's the solution to solving some of these problems sometimes. Some of you don't know that 1 is equal to 3 plus 4. Okay? And the way to prove that is that if 2 plus 3 plus 4 right, is equal to 180. Whoops. Wait a second. I wrote that wrong. Why is it not drawing that? Okay, there we go. We also know that 1 plus 2 is 180, right? This is on a line. So I'm going to write that backwards. I'm going to write 2 plus 1 is equal to 180. Okay, if both of those are true, and they are, doesn't it follow that 3 plus 4 are equal to the same amount as 1? And that's what Maya claimed. Okay, so let's see where they're going to go with this. Now that I kind of explained the rules to you and the logic, let's see if actually one of the answers actually is what I just showed you guys. So it says 1 and 2 are equal to 90. That's false. We don't know that 1 and 2 are equal to 90. They might turn out to be, but we don't know. We don't know. And 3 and 4 is equal to 90. We also don't know that either. It might turn out to be true. Okay, so this says must. So it turns out that A could be true, but it doesn't have to be. So therefore, A is not the answer. Okay, B, 1 and 2 is 180. That's true. And 3 and 4 is equal to 180. No. 2 plus 3 plus 4 is 180. So this is false. So we have a true and a false. Therefore, it must be false. So B is not the answer. Okay, C. 1 plus 2 is 90. We already said that was false. And then 3 plus 4 plus 2. No, 3 plus 4 plus 2 is 180. So that's false. So false and false is false. So that's out. So if we did this right, the last one should be. So 1 plus 2 is 180. That's what we talked about before, right? That's what I did on my second line right there. And 3 plus 4 plus 2, which is my first line, just not in the same order, is 180. So it basically means the sum of the angles on a line is 180, at least on the one side of it, and the sum of the interior angles of a triangle is 180, of course. All right, just to be safe, let me just see if I can do one more question. If it looks like it's going to be too bad, I'm just going to skip it. Okay, I can already see that looks involved. That's 37. But you know what? Let's make that the last example. And we go out with a bang, right? Let's make sure that's fitting on the screen. Yes, it is. Okay. The illustration, this is a 3D representation of something. It looks like the base is a square, and obviously that's a pyramid. So this is what's called the rectangular pyramid because the square is a rectangle. And we can see that the base is a 4x4. That's how we know it's a square. And the height of the rectangular pyramid is 10. That's it. Nothing, no rocket science here. Okay. Now there's something funny that's happening. There's this gray shaded thingy here. And what that means is they're trying to show you a surface view of it. If that was like a giant cutter, a guillotine or something, where it's going to come through the top at the apex of the pyramid here and slice through down through the middle. I'm assuming that this ends up being 2 here and this 2 here. Okay. And assuming they're showing the dotted line here because the surface of that grayish thing is probably making a right angle with everything along that plane, PLANE, right? There's different planes. So something's going down there to basically split this triangular pyramid in half, exactly symmetrically in half, okay? So that when it's split, the left-hand side, so to speak, looks exactly in all shapes or form like the right-hand side. Even if you drop them or turn them upside down, they would be congruent shapes when you end up getting the two of them separated together, right? So that's what's going on there, all right? Most likely this means we're going to have to look at that view. It's probably going to ask us to look at this as if we were behind the thing and see what that face might be. Now, I don't know. So imagine if you cut that way and you were looking straight on it, though. I put the angle, but I was doing it to make sure that you could see because there's a slant here. So I wanted that to be clear. But basically make sure that you were looking straight on it after it was cut in half, right? So if we view that, and I'll try to do this to scale. The face of the triangular pyramid, where the actual cut is, right? The gray thing is not part of the thing. It's only the knife that would go through it. So once the two rectangular pyramid pieces were separate, the congruent pieces, if you just turned one and faced it to you and looked at the the part where it actually got cut, it would just look like a triangle, right? And I'll color that and we can almost see it here, or outline it at least. If we go from here to here, okay, and from here to there, okay, and then there's a second line here, it's hard to see, but right there to there, okay, it's a triangle, okay? Within here, there's depth to it, right? If I draw the depth now, which will be this base part here, right? We're looking straight onto it. It would go back like that. Oh, that's a sloppy line, but in any event. So then behind it, you would have the slanted pieces, right? This face here, I'll use another color. This face here is slanted, right? We know it's slanted because it goes from the apex that's all touching to eventually being the two apart over here, okay? So that purple gives it the depth. So there would be a second piece that looks exactly like the piece I drew that we could place on top of it from facing it, right? Where they would go together and make back the original figure, all right? So I don't know if that's going to ask us, but I'm pretty sure it is. And they might even ask us the area of it or something. So that's what's going on there. At least if they don't ask us that, at least we covered it conceptually. So it says, let's now look at the words. The dimensions of a square right pyramid. So square pyramid means the base is a square. It's right because it's not twisted in any way. It's each side, each face is exactly equal. It's not twisted in some way. It's a regular pyramid, right? There's irregular shapes. For instance, like we know we can have, say, a shape like this, right? This is a six-sided figure, normally called a hexagon. I can take one of the sides. So first of all, this is a regular hexagon. If I was to change that side there and make it like this, in other words, get rid of this, and just be the green as if I had this. Right? This is still a hexagon. It's just not a regular hexagon. It still has six sides. All right? So that's what they're talking about here. This is a pyramid. That's why it's a right one. It has right angles on it. Okay? When you drew that line through it, the gray thing through it, it's a right pyramid. It's formal. So that it's not lopsided in any way. All right? So let's scroll some of that up to actually finally see what the question might finally be. I'm not sure the question's showing for you guys, so let me bring that over a little more. Let me get this so we can get some of the choices here as well. Whoops. Let's bring that up a little higher. I want to make sure I can get all the answers at once, maybe, without the illustration being gone. And this will definitely be our last question. Okay, so the pyramid is sliced by a plane, so that's the gray thing, that passes vertically through the top vertex. So that's where all the points meet at the top, the vertex, and is perpendicular to the base. So it's at right angles to the base. So that's some of what I talked about already. What is the resulting two-dimensional shape and the area of the plane section? So we already talked about that the two-dimensional shape, if we were looking at what I did, is the red there, okay? If we look straight at it from the arrows I showed and the red with the purple in the background, that's a triangle. So already we can rule out C and D. There's no rectangle. The only thing that possibly a rectangle is the two bases. Okay? So there's two parts going on there. It's a certain shape width. So both parts have to be true. And then there's the certain thing about the area. Okay? So now we need to figure out the area of the the um uh the the rectangular pyramid. Ugh. So that's what we have going on there. All right. So what we need to do is go and now find out what that formula is. Okay. So this requires you again to know what your formulas are, and I had showed that a couple of times ago. Let me see if I have that available on here. Um, could it be this? Let me see here. I think I had the grade 8 one on here somewhere too. Give me 1 second. All right, can you guys see that? Okay, it actually doesn't have it. It says the volume equals 8H, but you guys should know this because you should have worked with pyramids and stuff before. So that's